Hi, everyone. Let's see. Okay, we are recording. Hi, everyone. Welcome to Talk Math with Your Friends. We are really excited to have you here. Today's speaker is going to be Nenad Radakovic. Nenad is a professor and assistant professor in the teacher education department at my university, the College of Charleston. And he studies math education, and he is going to lead us through his presentation today about rich mathematical tasks and what kinds of things are rich mathematical tasks for classrooms. Nenad, we'll hand it over to you.
Okay, thank you. Let me just start with saying that I have posted a Jamboard link and something that we're going to take a look at, and I'm going to post it again. Or if somebody can somebody get in and then kind of copy and paste it again? Is that possible? Or
Done.
Okay, cool. Thank you. Just one moment. Let's just keep it like this. And then, so I want to talk about rich mathematical tasks. And basically the question is, how do we create math problems or math tasks or even math projects that truly engage students? And my work is mostly with pre-service teachers. It means future elementary school teachers and early childhood teachers, some middle grade students and some high school. And most of those students have not really had a good relationship with mathematics. So the idea of somebody who was bombarded with bad tasks or this task that they were not really engaging, now they have to create their own tasks. So what often happens, they just try to replicate bad mathematical questions that they were asked before. They are just maybe kill and drill worksheet type of questions. And so here's the caveat. I'm in math education. I'm a math education professor, and I can get very technical about different theoretical frameworks and different studies. All right. Okay, let me go back to this now. Let's say, so this is not going to be a typical academic math education talk. I'm going to use multiple frameworks and multiple ideas. But there are many more, and I'm going to mention some of those just in case that you're interested. So the questions that I'm going to be asking is, the first question is, how do individuals notice mathematics? Most of us, we know how we notice mathematics. We're trained to notice it. But how do we get future teachers and also students to notice more, to ask questions, to make connections? And, how do we create better mathematical tasks? So here's the plan. So we're going to start with actually introduction, which is reading poetry, or what I call, we don't see the same thing, and that's okay. So I'm going to have you actually be engaged in reading a poem. And I'm going to actually start with just reading several lines, and let's get into breakout rooms and start talking about this. And let me do the presentation mode. So this is a poem that I found in a book called Patterns in Mathematics and Poetry about maybe 8 years ago. And it's called The Love Letter, and it's by Japanese poet Nanao Sakaki. So it starts like this. Within a circle of 1 meter, you sit, pray, and sing. Within a shelter 10 meters large, you sleep well, rain sounds a lullaby. Within a field 100 meters large, grow rice and raise goats. Within a valley 1,000 meters large, gather firewood, water wild vegetables, and amanitas. And then it keeps going. And then kind of switches to kilometers eventually. Within a circle 10 billion kilometers large, pop far out of the solar system mandala. And then kind of ends with, within a circle 1 billion light years large, Andromeda is melting away into snowing cherry flowers. And now within a circle 10 billion light years large, all thoughts of time, space are burnt away. There again, you sit, pray, and sing. You sit, pray, and sing. And so here's the poem that I was very excited about when I saw it, and I wanted to share with my students and have them create similar poems. So what I would like you to do is, so if you look at the Jamboard, and I've created different groups because I wasn't really sure how many people are going to be on the call. And so the poem is kind of broken down into 2 pages. And I would like you to think about, what do you notice? What do you wonder? What connections can you make? And if you haven't used Jamboard before, you have a bunch of pens that you could use in different colors. I recommend there's a text option, but actually if you use these nice little Post-its, they're actually more user-friendly. So you can write your note here. And you can also use a different program if you want to create like a little representation. You know, you can use a GeoGebra and create a picture, and then you can you know, create whatever you want to create there, and then you can screenshot it. So it's very user friendly. And let me just check the questions. Oh yeah, so here's the link. Thank you. Let me just see thumbs up. I see Spencer Bagley on the call. This sounds like a legit name.
It is.
So so I'll admit it. I guess somebody already admitted him. Okay, so let me just see thumbs up if you're okay with using Jamboard and okay with reading poetry now. So I'm gonna go ahead. So it looks like people are pretty good. So let's notice some themes and some things in these poems. And it doesn't look like I have a breakout room here option, and if somebody can create that for me. And Monica yeah, go ahead.
How many breakout rooms do we want? I see
maybe about people. 4. Can we how many people do we have on the call right now?
27.
Okay, so I have 6 groups so that I created. So I guess we could do that.
Okay, let me hit create. And do we want a time limit or?
Yeah, let's do about 7 minutes, and then if we need more time.
Okay, I'll set a timer for 7 minutes and should open now.
I think everybody's back, or most of people are. Okay, good. Right, so please just take a minute to see what other people wrote about this and what connections everybody's making about this poem. Okay, just for the sake of time, and I'm gonna just ignore like a regular pedagogy of undergraduate classes where people sometimes don't really talk that much, and then I have to really structure it. Just if anybody wants to share anything that they noticed or anything they wonder, either in comments or in a chat, or just speak up. Can everybody hear me now? Okay, cool. If you can either in a chat or anything that you find interesting, either from your comments or someone else's comments.
One of the last things that my group was talking about was how, at the start of this, we're thinking about this circle that has a radius and a center, and it's the narrator at the center, and we're each our own narrators. We're all thinking about what's within 10 kilometers of me. But then by the end of this, like the center doesn't matter. Like we're all the same center at that kind of scale. There's like some kind of collapse of all of us into like the pale blue dot speckness. And then Cameron said something really interesting, which was, but are these circles or are they spheres? Like at some point for some of us, they went from being like flat, two-dimensional little circles around your house to being spherical in nature. And like when and where did that transition happen?
Any other wonderings or noticings about this? Oh, somebody noticed the connection with that powers of 10 video when things get smaller or bigger. There's also the Simpsons version, if you ever seen that one. It's hilarious. Okay. Kate, can you tell us more, Kate, about cherry blossom and Andromeda connection?
Yeah, I thought it was really lovely. I don't know, that's the one that stuck out to me the most, just the idea of something like so small and delicate being linked to something that's so much ginormously larger of scale. And someone else in my group said about the spaced out yellow mustard blossoms representing stars in the same way, the juxtaposition between things that are small and delicate and sort of ordinary beauty every day being linked up with something that's very large and also has that same kind of ordinary beauty that we see every day.
Yeah, this idea somebody mentioned, the real, Kian mentioned, the really cosmically scaled stuff was still described as terrestrial language, blooming, snowing.
Exactly, that's exactly it. I thought that was really cool.
Yeah, the idea of natural beauty. Okay, so we can make those connections, keep making connections, and yeah. So, what do you think, Tian, of this idea of you? Can you tell us more about what we talked about? Who is you, and how that worked?
I don't know that in our group we actually resolved this. We weren't sure just based on what was saying, like if you was a consistent you throughout the poem as it progressed. But the reason I asked the Buddhism question was because in Buddhism there's a sense of the idea of a you being sort of illusory, right? Like the best analogy I've seen is like if there's two different whirlwinds or two hurricanes, they're not actually separate entities, they're just manifestations of one global like atmospheric event. And so who is you, as you or you a plural, or is there even any meaningful distinction between that? It's not clear.
And Josh said that so the scales are supposed to be getting bigger roughly the same rate, but there's a huge jumps. It's almost like logarithmic, right? And then, but they represent, yeah, the connection broke also. Yeah, there's there's that like kind of power of 10 sequence, but then it kind of gets broken too at some point. Yeah. And that's cool. Like a lot of questions about scale, about distance, about quantity. This idea about a lot of educators talk about number sense, but there's also quantity sense. How big is something? How big is a billion? How big is a light year, etc. And this is something that at some point, even people who are trained to think about this, there is a disconnect. And yeah, so visualizing cosmic distances, that is the problem. All right, so I just we could talk forever, and I could talk forever about this poem. And I also recommend his other poems. But so I got really excited about this poem. And then I shared it with pre-service teachers, and they, they loved the poem, and they really engaged with it. And the idea is that here's the example of a poem that was created by a pre-service teacher. Within a circle 1 meter, I wake up a few minutes before my alarm. Within a circle 10 meters, I walk to my car and drive to the grade school. Within a circle 100 meters wide, I arrive in my classroom and am greeted by their smiling faces. And within a circle of 1,000 meters, I am feeling nervous about teaching my first whole class lesson. From the point of view of engagement with poetry and mathematics, I read this, that you can kind of read the kind of anxiety and excitement about being a teacher. But as I was having this disciplinary engagement and involvement with mathematics, I started to question the scale, right, of the student that they were using. And is the scale just kind of something that they copied from the original poem? Because within a circle of kilometer, I'm feeling nervous about teaching my first whole class lesson. Or, myself as a teacher and a math educator, I can start now seeing where's the deeper kind of mathematical connection. And which really brings us to this. So there's like a stuff about light year, and we're having a rich connection about mathematics and physics and even religion, but it brings us to the point that this is from the paper that I wrote and the article that I published with colleagues Susan Jagger and Limin Zhao. And when we gave these questions to pre-service teachers, is our engagement with mathematical poetry was quite different from that of our students. So I saw different things than what my students saw. We found it necessary, rather than me starting to trash this poem about lack of connections and in similar poems, I found it necessary to embrace multiplicity of meanings, right? And that we all have different a relationship with a poem. And if this was a part of a different community, and we already did that, we talked about religion, we talked about God, we talked about beauty. If we belong to a different community, we would maybe have a different conversations too. And but what happens here is we did create space for students to start to engage with mathematics. And which brought me to different ways that I also engage students in mathematics in my classes. And one of them is, rather than having a poem and an object, is the trail, the math trail. I don't know if you know much about math trails that kind of also bring this kind of connection. So I'm not going to spend too much time on this, but with my pre-service teachers, every semester we visit either, I'm in Charleston, South Carolina, we visit the Halsey Institute of Contemporary Art. And again, I have students notice and look at different objects and try to make sense of them. And also Mays Brown Natural History Museum. And I got an idea from the curators of a museum and to have my students, pre-service teachers, start collecting questions, mathematical questions that they could, give to different groups of students, mostly elementary, but also middle grades. And I got really excited. And because the museum is beautiful, it has everything from, Nautilus shells to like a T-Rex and mastodons and etc. So there are a lot of connections. And then again, it's about noticing, just like in a poem. And when I gave them to write questions for students, this is what they came up with. This was like predominantly questions that teachers had. Kind of Megalodon has 276 teeth and T-Rex has 60 teeth. How many teeth do they have together? So I'm thinking about this beautiful experience of reading a poem and getting like kind of engaged in all of these imagery, or going to a museum and seeing these beautiful objects. And, students have all kinds of questions and they're curious. And everything that comes down to is, basically a worksheet question about add these teeth together, which doesn't really have much context or meaning or anything else. So it got me thinking more about rich tasks. What does it mean to have a rich task? And I apologize to people on the call that may be in math education and may have like, even more experience with tasks. But so I'm not going to get much into theory, but I love the Catrier's and colleagues' description of juicy tasks. The tasks that are juicy, meaning they're kind of, you look at the task and it kind of spills out into different areas. They're engaging, etc. Or Joe Buller's idea of rich tasks, or idea that Van der Waal has about worthwhile task. And I'm thinking of those tasks as being, one of the words is kind of low floor, high ceiling, meaning everybody can enter and start enjoying these tasks. And there are so many, many, many layers to them, just like there are so many layers to the poem. And I want tasks that are not about adding teeth. I want students to think and reason about the task rather than perform simple procedure. And I want students to make connections. In math education, we have this kind of, it comes from a psychology theory called connectivism, that what is deep learning and learning about anything. It's not how fast you can add two numbers. It's about making connections between the visual and symbolic and verbal and context and a physical representation, and making all these. So your learning is about making the web of connections. It's not how fast you can integrate, right? That's not what learning mathematics or anything else should be about. So what I'm going to do now is I took, my students took a couple of pictures from the museum, and keep in mind about this idea of what makes something a worthwhile task in mathematics. And maybe you can add your own ideas about that. And I want you to, just for the sake of time, so here's a picture from the museum. What would you ask students? And this can be any level. What kind of worthwhile task could you come up with? So let's do, and I'm thinking just to give you several, maybe, let's do this one, or you can also pick this one. Here's another picture. This is a giant armadillo, I believe. I don't know what the term is. And then here's another one. So on a Jamboard, I didn't create groups like I did here, but if you can go on a Jamboard, you can pick any of these 3 pictures and come up with some problems, some questions that you would like your students to answer. And think about whatever level you're working in. It can be high school, it could be early, 2nd grade, it could be calculus students. So take a look at these, pick ones that speak to you, and we can spend And multiple groups can work on the same one. If you want, you can take a picture, you can copy it and move it to a different frame, whatever you want to do. But think about this idea, low floor, everybody can enter it, like all students can start participating and thinking about it. But there's high ceiling to it. So many different choices. It's about thinking and reasoning, making connections, etc. And I'm thinking we can do breakout room for about, let's do 10 minutes. Right, welcome back. If you can just take a look at the Jamboards for a second, just to see what people have done for each one of those. So here's the shark teeth one, and the armadillo, and the jaws. Nice. Okay, so I just want to show you, well, first of all, if somebody who was in the shark teeth group, or if you worked on this problem, if you can tell us about your question, and also if you can kind of summarize some of the questions that you talked about. Let's start with that.
Well, I'll pick one from my group. In my group, one of the things that we talked about was if there was a way to predict the size of the animal based on the size of the tooth, like if that would be somehow predictive to figure out how large each of these sharks were or are.
We thought about sorting the teeth, maybe sorting them by physical properties and see if that matched the biological sorting that they had been given. And we also thought about sort of like modeling the loss of teeth over time for sharks, and also maybe thinking about the age, sort of like the size of the shark kind of question that Kate was talking about.
And how do you think that some of these questions that you were asking kind of connects with this idea that you are encouraging students to think and reason, that you are connecting it contextually with mathematics, and that you have a variety of strategies, or maybe even this idea that because we want everybody to be able to participate, to start with thinking about these questions, no matter what their, knowledge of mathematics is. So how do these questions connect with these goals?
Well, we talked about how a student could choose a level of precision when engaging some of these tasks. And so it was pretty flexible there. And if they got overwhelmed, they could sort of scale it back down and simplify things. And I think we were also really focused on questions where there wasn't an answer, so where the tasks were about, think about good choices for modeling and why you made those choices and what the implications are.
Yes. Kind of keeping it open like that. I think these sorting or classifying questions seem to be very, very cool and very interesting. So let's kind of show now that I gave my students a little bit of guidance in what it means to have a rich mathematical question. I'm going to just show you an example, kind of what student came up with. And let's say I think this was like a second or third grade task. So think about also, grade level, grade 1 through 3. So let's take a look at this question. And does it have some of the elements of a rich task? What can we do to make it even more open, or more like kind of low floor, high ceiling? Yeah, you will find that a lot when teachers are trying to make math questions. Is that they go to the they look at the standards, and they look at the kind of words in the standard, and one of them is a pattern. So do we even have to talk about patterns here?
This makes me uncomfortable because I don't care to do this.
Yeah.
I,
You don't care to
I mean,
finding a pattern, or knowing how many teeth there are?
I mean, I would count them. That seems like a reasonable way to count how many teeth there are.
Yeah.
I don't know that because the way that they're displayed in the case is not in a grid in any way. Really.
Yeah.
You could argue that there are 3 rows. Maybe.
Well, let's see what other people say.
But it seems like a stretch to me, I would say, to then, like, it seems unintuitive. And for me, so much of mathematics is like, what does your intuition tell you about how to move on?
At the first grade level, what I would expect a child to say in response to that is like, well, that's a group of 4, that's a group of 4. Rather than looking at the whole thing for something more rigid, they're supposed to be like noticing up to 5 really quickly. And so those sort of like the same thing where you see on Twitter where people take a picture of like an object and like, how did you count them? And I'm like, oh, I play cards, so I saw those as 5s really quickly. It's probably what I would expect to happen.
What we call sabotaging, right?
Yes.
So the idea what this student had for this task was kind of inspired by those counting tasks that we see a lot in education, and it would be if without counting these, how do you see, what's the structure? What do you see? How did you count those? And students may say, well, 3 rows or 4 rows of teeth, or student may divide it into smaller numbers, etc.
It seems to me like that takes away from we're looking at teeth. We're looking at things which are very different from one to the next. And I think it almost feels like sabotage to say, now think of them all as single units.
Yeah, maybe what this task is missing is that idea of connection between the context and mathematics in a way.
Yeah, perhaps maybe something like a combination of what we were talking about before in terms of categorizing, like put them into categories and then count them.
Yeah.
How much in each, like that, if you cared for it to be a counting task.
I like
It
this.
seems to have lost the context of being from an animal or being from a shark. Like I want to connect what we're looking at to some mathematics, but then link that idea back to the biology or back to the habitat or back to the animal in some way.
Yeah.
And just counting them doesn't tell me anything about sharks, right? I can count anything. This is fine. But I want to measure something and then make a conjecture about some kind of fish.
Nice. Okay, just for the sake of time, I think we could talk about this forever. Let's look at the armadillo and just we can briefly look at some of the questions. I was in this group. I just want to say that there was a lot of conversation about why there seem to be mostly kind of rectangular looking things in the middle and not so much on the side. So that was a cool question. I'm also trying to follow the chat conversations. There was a cool one about, I wonder what the display maker for the shark teeth, what was their intention? But, but the questions about armadillo, it was about surface area, about covering, what's the efficient way to cover. There was also a question, maybe what's the link between this and the graph theory, or maybe, you know, coloring problem, etc. So let's take a look at what the teacher wrote. Again, you can think about this also like maybe second, third, fourth grade level. What do you like about this? What makes you, you know, wanted to kind of rewrite it, or take consider these ideas also about how it connects to context. How does it make students think or just like repeat what they already know, etc. Yeah. See, I don't like this idea about organic and geometric shapes. For me, all shapes are shapes, right? And I think there's a lot of, in school mathematics, there's this huge focus on having students just, when you say a geometric shape, to think about triangles and circles, etc. And I think it kind of kills the richness. But if anybody has more insight into this, as an educator, I think it's just this category that educators made up, but it could be also, maybe it comes from art. I'm not really sure. If anybody knows, I would love to know. Yeah, they are pesticide free. I think organic is what you find in real life, and then geometric are kind of ideal platonic shapes. Maybe that's the idea. But I know a lot of my students very much care about this. A lot of teachers care about this, and I think it kind of kills the joy of mathematics. Yeah. Mm-hmm. Yeah, this idea about approximation, and the reason why the original questions were, when students were answering this, they would say, well, I see here rectangles. And the idea was, my question was, where's the rectangle exactly? Right? Just like a similar to, here's another picture. Let me see if I have it here. Here is a picture here of a fountain, and on the floor, my students would say that the shape here is a triangle, right? And so I think some of these questions came out of those, maybe some of those conversations. But just for the sake of time, it's 4:26. What I wanted to raise, the questions I wanted to raise was, what goes into making good tasks, and how can we have teachers that are teaching future mathematicians start asking those questions? And then here's the third one. Please take a look at the Jamboard if you want to just see what people wrote. But just for the sake of time, this is what I'm now thinking about when I have my teachers design questions. And this is not you know, I have not done any formal studies with this. So first start with asking questions and wondering. Don't go straight into creating a task. I think that's what was really fascinating to see what you did was you didn't go straight into writing a mathematical question about, teeth or whatever. You first started wondering and asking questions. So that's what I start with my students first. So start asking questions. Okay, what do you see? What do you wonder? And then use these 3 criteria. Why do we care about how many teeth this animal has? Right? How does it relate to real questions that kids want to know? How large was this animal? I think this was one of the questions about this jaw. How big is this shark or whatever this is, right? Just based on this scale here, how big is it? How long is it? How can we know? Right? So I teach them about these criteria, and then they create a task, and then their peers can give them some ideas. I give them some idea, and then they resubmit it. But I say, going from the question about, adding shark teeth, from this question, then doing more, which is more, I gave you some kind of middle of the road questions, I would say, that teachers did. And then finally, improving on their ability of asking questions is what I'm interested in. And I hope that I think I gave you more questions than answers. I want you to think about this. I would like also calculus teachers to think about what questions you are giving, because I know that when I was taking calculus or linear algebra or whatever, that often, the textbook questions were, quite superficial too. So how can we have students start asking these questions? Okay. It's 4:30 now, and this really flew really fast. Yeah, so you're right. Those are exercises, not questions, right? Mm-hmm.
All right, everybody.
Yeah.
I was going to say if we could unmute and everybody give Nenad a round of applause.
Thank you so much.
We'll stick around and have some more conversation and some questions if you want to hang out and talk for a minute. But before we do that, I wanted to do a share of next week's Talk Math with Your Friends. So next week, we will be hearing from Brian Lee of the University of Toronto. He's going to tell us about a magic trick using the set deck, which is something that everyone has some experience with. It reminds me of classifying all of those shark's teeth that we were talking about a few minutes ago and sorting them around. So we're looking forward to that. So please hang out and stick around and we'll talk a little bit more.